Good morning everyone, and welcome to the next video in the cybersecurity space. This video we are going to discuss about the Certified Ethical Hacking version 10 tutorial. Now the CEH version 10 course comes from an organization called EC Council, and we're going to discuss in depth what this course is all about, what ethical hacking is all about, and we'll be discussing a lot of aspects. Now this is what we're going to discuss. Who is a certified ethical hacker? What makes a certified ethical hacker? What skills would be required? And what would be the expectation? What is CH version 10 and how would this certification help you become a certified ethical hacker? What is new in version 10? So what's the difference between the previous versions and what has been introduced in this version that is going to benefit us more? Then we're looking at the roles and responsibilities that are required of a certified ethical hacker, and why would people want to become a certified ethical hacker in the first place? What are the career options and what would they be required for? And then we're going to look at the exam. We're going to look at an overview. We're going to look at how the exam is structured, what domains are there in the exam, what weightage these domains have, and we're going to look at a sample questions as well. We're going to discuss those questions and we're going to discuss the answers and why those answers are correct, why the other options in those answers are not. Then we'll be looking at job roles after CH version 10, which you would be eligible to apply for. And based on the knowledge that you have, you can get these kind of job roles. And these job roles will also help you understand what kind of requirements there are in the marketplace as well. So you can study from that perspective. And then we'll be looking at what kind of a salary to expect from a certified ethical hacker. Now let's begin with who is a certified ethical hacker. A certified ethical hacker is a person who's also known as an ethical hacker. An ethical hacker is just the opposite of an hacker. A hacker is a person who with malicious intent tries to misuse vulnerabilities that they have identified in an organization structure and then gain access to unauthorized data. Whereas an ethical hacker does the same thing. They try to locate the weakness, they try to locate the vulnerabilities, and they see how they can be misused. However, the intent is completely different. And that is what differentiates a hacker from an ethical hacker. Hacker would be a criminal with a malicious intent who would try to misuse and personally gain by doing criminal activity from that particular activity that they have done. Whereas an ethical hacker would try to help the organization in an authorized manner. So that's where the permission comes into the picture. The ethical hacker has permission from the organization to conduct some activity that would identify vulnerabilities or weaknesses in the information technology structure of that organization. And then once they have been identified, the ethical hacker would then help the organization to plug those vulnerabilities rather than misuse those vulnerabilities. So any person who completes CH version 10 certification is known as a certified ethical hacker. So there's a certification. Once you complete that, once you pass the exams, you can essentially call yourself as a certified ethical hacker, and you're going to get a certificate with the same terminology. So as you can see in the diagram, your responsibility would be as a certified ethical hacker would be with the proper permission of the organization. With the authorization coming in, with contracts coming in, you would legally help the organization to identify those weaknesses and vulnerabilities. And once you find them, you're going to report them to the organization, and you're going to help the organization with remediation plan, which would help them remediate, mitigate, and resolve the vulnerabilities that you have identified, thus making the organization's security structure a lot better, based on which black hat hackers or malicious hackers would be unable to attack the organization. So what is CH version 10? Now this course was initially introduced in September 2015, and I think if you look at the versioning, this is the 10th version that is there in the market. So essentially CEH, or the Certified Ethical Hacking course, as the course itself has been for a long time in the industry. It's a very well accepted course and it's a well-renowned course. The current version as it is was introduced in September 2015 and is one of the toughest certifications in the cybersecurity field. This includes a lot of information that you have to learn, that you have to know before you can attempt the certification. You will master all ethical hacking methodologies that are used in penetration testing and ethical hacking situations. What does that mean? That means that CEH version 10 is a structured course that will help you look at all the phases that are used in ethical hacking, all the terminologies that are utilized, all the tools that are utilized in such a manner that you can penetration test or a vulnerability assessment and identify and test the vulnerabilities for their complexity. And this course, once you complete the course, you would have mastered all the ethical hacking techniques that are required. There are two exams. One is a written exam and the other is a practical exam. Now you can opt for either or. The written exam is basically a multiple choice question exam where they'll ask you scenario based questions and you have to answer those questions. That is something that we're going to look into during this video. The practical exam is basically a simulation exam where they give you a scenario and you have to complete those tests and prove that you are a good ethical hacker. Based on the report that you give, if the report tallies to what the test was, you would be clearing that exam. So practical exam is a little bit tougher. It's more hands-on. It tests this actual skills that you would perform in a hacking scenario or a ethical hacking scenario. Thus the practical exam going to be that much tougher. The written exam, to give it credence, tests you a lot on your mentality, on your thought process, on your judgment characteristics. So they will give you a scenario and ask you what do you think is happening, what does this attack tantamount to, or what would be the next step in the particular attack that they're describing. Thus it's more of an intellectual test where when your thought processes are being checked and you are giving those exams. So what would be the difference between these exams? In a practical exam, you would be conducting all those steps yourself and you would be reaching a conclusion. So here essentially you're being tested on the skills that you have developed on the execution part of it and to see whether you can execute a test end to end. Whereas in a written exam, you would be put in the middle of a test where you have to assume something, where you have to understand what the steps would have been performed in the previous steps and what would be the expected result, and you're supposed to analyze that and then come to the correct answer. So if there is a question which exam is better, written or practical, the answer to that is from an intellectual perspective, a written exam would be a lot tougher than a practical exam, and from an execution perspective, a practical exam would be tougher than a written exam. So it depends on us which exam we want to give. Both of them are widely accepted and well respected in the information security field. So it's just the option that we choose which exam we want to give. Now, this course, the version 10 course, is purely attack-based course. Okay, it is an offensive course. There is no defensive mechanisms. So if you're looking for questions of how to secure yourself on the internet, how to securely configure an operating system, or how to securely configure a server, how to configure a firewall, this is not the certification. This basically talks about attacking those devices. So if you come across a firewall, how would you test a firewall? How would you identify vulnerabilities in those? And how would you bypass a firewall? Similarly, if you come across a server, how are you going to attack and hack the server? Let it be Windows or Linux based. So this basically becomes an attack based course. You're looking at offensive mechanisms over here and not defensive ones at all. So what's new in this version? In this version, there's a new module for IoT, Internet of Things. It focuses on emerging attacks, vectors like cloud, artificial intelligence, and machine learning. It basically talks about smart devices. And it talks about the vulnerabilities, the risks that the smart devices face in today's world. For example, it will tell you about the industries that are utilizing all these smart devices, why are they utilizing it for, what kind of devices they are utilizing, and what are the risks within those devices. It will also give you a lot of tools for you to practice upon to identify such IoT devices. What would constitute an IoT or an Internet of Things device? Any device which has an IP address and can connect to the internet and create data. So even your smartwatch, your smartphone, your cars that have internet connectivity nowadays, your Google Homes, Amazon Alexas, all of these devices would come under the IoT umbrella. And have you ever wondered about sitting at home, having a Wi-Fi, having all of these devices, even a smart TV, if you will, connected to the Wi-Fi? And have you ever questioned how a hacker would then be able to access your home through all of these devices, record information, and basically just spy on you? Similarly, an organization where they are utilizing IoT, they would be vulnerable for the same vulnerabilities. And this course does include IoT security to a certain extent, where we talk about vulnerabilities and how to identify those vulnerabilities in IoT. Then there's a new vulnerability analysis module where it gives you risk assessment. It talks about CVSS scoring systems. It talks about how to do a vulnerability management program in the first place. What are the steps required in a vulnerability management program? How should it be repeatable and how it should be measurable as a program? And what should be the outcome? So basically, it will give you a structured way of how to do a vulnerability management assessment and how do you want to achieve the end goal, thus leading you to a penetration test. So all the modules are leveled up. What do you mean by leveled up? That means they've been updated to the latest tools, latest standards, latest technologies. So you've got cryptographic attacks, you have got attacks on applications like SQL injection, we'll be talking about packet sniffing using various tools. All of these are upgraded, which means they are up to the latest operating system. So even when we do this course, You'll be looking at operating systems like Windows 10, Windows 8, Windows Server 2012, Windows Server 2016, Kali Linux machines, Android machines, and Ubuntu desktop as well. So all of the operating systems are latest, the tools are latest, and you will be interacting with these tools. And then there's a mobile security toolkit as well, which will help you do a penetration test on a mobile device. So these are what is new in version 10. Now let's talk about the roles and responsibilities that an ethical hacker should have when they actually go into the world. Now, what are the responsibilities, roles, what are the capabilities that we should have? That we should be able to look at scripts that would test for vulnerabilities. So for example, a SQL injection attack, it's a script-based attack. Let's say a cross-site scripting attack, that is again going to be a script-based attack. So we maybe we want to go ahead a little bit, look at Windows systems and do a PowerShell attack and know about PowerShell scripting a little bit. If you look at Linux Windows, there's a bash shell where there's bash scripting, and you'll want to learn that scripting as well. Now the course doesn't include all these scripting languages. It does help you understand what these scripting languages are, and it does have some basic introduction to how these languages can be utilized to create those scripts. Then we also want to develop tools to increase security. You want to look at those commands that are utilized on all operating systems. You want to look at the capabilities of the operating systems, of how to create security parameters and ensure the operating systems and applications devices are secure. You should be able to perform risk assessment. Now, when you say risk assessment is the likelihood of an attack being actually executed on an organization based on the threats and the vulnerabilities that we have identified. So risk assessment is something that you find out a vulnerability and then you try to figure out in a hypothetical manner of what is the likelihood of that vulnerability being exploited by a hacker if they find that vulnerability. And if they do execute that, what is the impact that is going to happen on the organization, and what is the penalties or the repercussions that the organization is going to face if that vulnerability is exploited. That's what a risk assessment is. Then we should also be able to develop security policies or set up security policies and implement them to ensure that the security mechanisms are standardized and are consistent. And then we should also look at training staff for network security to ensure that they are aware of these vulnerabilities and they know what their responsibilities are to maintain some semblance of security in the organization. So why do we want to become a certified ethical hacker? Now, since you're watching this video, it's easy to assume that we all are interested in security, we all are interested in hacking, but hacking is not a real job. For us to get a job in the industry on a security parameter or information security parameter, we want to become a certified ethical hacker. So if you look at the popular hacking cases that have happened, in 1990s, there was a national crackdown on criminals. Microsoft NT operating system was hacked. Now this was back in the 90s when security wasn't that much evolved. And there were a lot of attacks back then that crippled infrastructure, that crippled banks, when they started realizing that computing isn't as easy as it seems. Of course, if you use a computer, the functionality is always there, but if the functionality is not properly configured, you're just exposing yourself to cyber criminals where they're going to steal information and your organization may just go bankrupt because of that. In 2013, an example, Adobe reported 2.9 million accounts as stolen. In 2016, Kaspersky, which is an internet security firm, announced that there were 758 million malicious attacks that occurred worldwide. Imagine that, 758 million malicious attacks that were identified and reported. In 2018, Facebook reported a loss of 30 million accounts that were stolen. 2018 again, Quora reported 100 million customer accounts being stolen. And in 2018 again, Marriott, 500 million travelers accounts stolen and manipulated. Now, when you say accounts were stolen, how does it affect the organizations? Now, first and foremost, if those accounts were stolen, that means usernames and passwords were cracked, and those accounts may have contained credit card information or may have contained some personal information that would identify the person and thus make them gullible for a social engineering attack or an identity theft attack. So it has a cascading effect. If I would have been affected, or you would have been affected with these attacks, the repercussions would have been catastrophic. Your credit card information being stolen, that means somebody else would have misused it and you would have seen a huge bill come your way. Now, you can go back to the bank and dispute that, but that's again a dispute that you're trying to have with the bank for something that you didn't do, which requires a lot of energy and a lot of time. And at the end of it, somebody has to pay for that particular loss. Now, in this scenario, the bank would have had to bear the loss, but then that's a loss for the bank and bank doesn't want to do that. And that's where they would try to hire certified ethical hackers who would try to test these vulnerabilities and plug them in so that the end consumer is also secured, the bank is also secured, right? In this case, Marriott, there were 500 million travelers accounts that were stolen. A lot of credit card information was leaked out. Email accounts were hacked and compromised. And thus there was a lot of repercussion that happened. Now, the thing is that there are also laws that these organizations need to adhere to that tell the organizations how to keep their information secure, and also have penalties in place if the organization gets hacked. And the penalties are pretty severe. So organizations do not want to get hacked or do not want to get compromised, not only from the customer's perspective, where they would be losing customers, losing reputations, and then thus facing losses, but also from a legislative perspective, where they would have to pay fines to the government for the frauds that have happened. So these are some of the popular hacking cases that have cost these organizations quite a lot of money, and thus they have a lot of security in mind. If you look at the news, in BBC News, there was something reported from a French police that there was a virus that infected more than 850,000 computers worldwide. Now, on the similar lines, if you remember ransomwares, and if you look at WannaCry that happened in 2018 or 2017, it also cost the world $4 billion in losses during that just one small month of its infection. Then Google basically disclosed that a large-scale hacking effort was targeted at Apple devices. And this has been, it has reported that there was a sustained effort to hack iPhones over a period of at least 2 years, which means that there's a specific target towards Apple consumers, and they are at a higher risk of getting hacked than others. Then the Texas government organizations hit by ransomware attack. So hackers have infected 23 organizations connected to local government in the US state of Texas with ransomware. That means that their databases have been encrypted. The government themselves do not have access to that database. The databases could have been compromised by the hackers. And that means that whatever services were being provided to the users based on that database may no longer be available to the end users because of the ransomware. Now, moving on with these, why do we want to become a certified ethical hacker? Increased attacks lead to more job openings. Now, if you look at ransomware, the WannaCry attack that happened in 2017, there was a knee-jerk reaction given by the rest of the world for IT security. Suddenly budgets started opening up. Suddenly people wanted more ethical hackers on their payrolls to test for vulnerabilities. In UK and Europe, we have GDPR, which is again another law that imposes severe penalties on organizations that get hacked and for not having proper security and a vulnerability assessment and penetration testing program in place. So that leads to a lot of job requirements as well, where organizations look at people with this special skill set to help them mitigate the vulnerabilities, to safeguard them and their customers from hackers, and also from penalties from law enforcement and governments. So thus the demand keeps on increasing for ethical hackers, which automatically means that the salaries are going to increase as well. So more the demand, lesser the supply, higher the salaries. That's plain economics. Then challenge hacker with malicious intent. So from an ethical hacker's perspective, it is our duty to safeguard an organization, which means that we'll be pitched against hackers, and we have to ensure that those hackers would be challenged to the maximum limit before they even try to get access to any of the resources that we are trying to protect. It offers a boost in your career. So more efforts that you put in, more vulnerabilities that you find, the better the career prospects that you have, and the better job aspects that you're going to get. And this also lets you keep yourself updated on the latest technology. As the technology progresses, as we evolve on technology, security will also evolve, and the ethical hacker would need to keep themselves updated on these technologies. So this is what is a plus point to become a certified ethical hacker. Now let's look at the exam that you might have to give for the CEH version 10 certification. So CEH stands for Certified Ethical Hacker. The current version is version 10. Like discussed, there are two different exams. One is a written exam, and when we say written, you don't have to actually write something down. It's a multiple choice question. So you'll be asked a question, you'll be given 4 options. You have to choose the correct option according to your knowledge, and then you will be judged whether the answer is correct or not. The governing body who issues the certification is known as EC Council, which is a globally well accepted authority. Exam has 125 questions, and the minimum passing question is around 60 to 85%. Now, there are no marks per se as such, but the grading happens on a percentile methodology. So the scoring is set by using statistical analysis and the scoring changes based on the difficulty of the questions that you're being asked. So if the questions are less difficult, your passing rate is going to be 85% out of a possible 100%. And if the questions are going to be difficult, then it may be around 60%. So it may vary a little bit. So I have seen people clear at 73%. I have seen people flunk at 75% based on the questions being asked. So the questions are asked, you answer them, and the results are out immediately. So once you submit the exam tells you how you have fared in the exam and whether you have cleared or not. In the practical exam, there are 20 practical challenges that are given to you with real world scenarios. So this is where you start executing those aspects. And so they basically would, let's say, give you a basic challenge saying, you know what, you're in a subnet, you're using Kali Linux or using a particular software, and you have to scan and identify the live machines that are there in that particular subnet. And then you try to do a ICMP ping. It may not work. You might want to do a different sort of pings to identify if the information that you're collecting is correct, and then you create a report and submit that. So in this scenario, you basically exhaust all the possibilities that you have learned about, and then analyze the response that you have given, and then you create a report about which live machines were there. And if that is correct, you would be clearing that exam. Now here again, we are talking about, I've just give you an example about what those practical exams would be like, but expect something advanced as well, where they've given you an application and you want to do a SQL injection attack, and they want you to identify those vulnerabilities, test those vulnerabilities, and create a report on what you have attempted, what was the response that you have created, and so on and so forth. So if it is a hackable application, they would expect you to go through the entire exercise and give out the report. Now the report comes with screenshots and proof that you have actually executed that as well, right? In this exam, there would be 70% passing that is required to clear the practical exam. So if you look at it, the theoretical exam would test you on your intellect to see how much knowledge you have about technologies, about scenarios, and how you're going to conduct the ethical hacking test, also with the effectiveness of which tools you're going to utilize. The practical one would be where you're going to execute those tests and you're going to create a report. The exam fee for either or, you won't be giving both of them together, so it's either or. Each exam would cost you around $500 from the EC Council's website. The exam duration for the written exam is 4 hours. The types of questions that will be asked to you are multiple choice questions. So they'll give you a scenario, a question, and then there would be 4 options which you need to choose from to identify which is the correct answer. And you'll have 125 such questions that you need to answer within 4 hours. Now 4 hours is 240 minutes. So we assume that 240 minutes and we got 125 questions. So we got a lot of time. However, the questions are scenario based, are quite lengthy. You have to read the question, understand, analyze the question, analyze the answer, and then try to give the correct answer. So here, the more knowledge that you have, the more hands-on knowledge that you have, the more analytical mind you're going to develop, right? So this would require a lot of practice as well. You cannot just read a few documents and say you become an ethical hacker and start giving an exam. So you need hands-on even for this exam. You need to know what exactly happens during a hack, what is the executed command, what should be the output of it. And based on that, you create a certain knowledge base in your mind, which can help you analyze these questions and answer them. The exam is only available in the language, in the English language, and it is an online exam. It is a proctored exam, so you would have a webcam watching you to ensure that you are not cheating. It is not an open book exam, neither can you use Google. So these are the aspects in which you're going to be tested in the theoretical exam. These are the 7 domains with their percentile as far as the weightage is concerned in the exam. So out of 125 questions, 23% of those questions would be towards security, 22% would be networking and background information, analysis and assessment would be 12%, ethics would be at 3%, 29% would be tools, systems and programs, 9% on procedure and methodology, and 2% on regulation and policy. Now let's start with networking and information background. So when you say network and communication technologies, we are talking about how networks work, how computers communicate with each other, the IEEE 802.3 standards, Ethernet, and so on and so forth. Then information security threats and attack vectors on networks themselves, and the technologies in the information security. So let's have a look at a couple of questions and see what these questions would be like. So networking and information background. At which layer of the OSI model does a proxy operate? So if you look at it, you first need to know what OSI model is, the Open Systems Interconnect. You need to know that there are 7 layers in the OSI model, and you need to know their functionality. So what happens at the physical layer? What is a network layer? What is a data link layer? And what is an application layer, right? And which protocols work on which layer? So at the data link layer, for example, for hacking, as far as we are concerned, we need to know that the data link layer takes care of MAC addressing. The network layer would take care of IP addressing and routing. Ports. Physical layer would basically be the physical layer where your RJ45, your network interface card, your cabling comes into the picture. The packet gets converted into electronic pulse and gets sent over the wire. The application layer is where applications interact with each other using some different protocols. So when you say a proxy generally operates at the application layer. It allows an application to connect. So this is some knowledge that we need to understand, we need to analyze. Now again, this is a basic question, this is an example question. In your exam, it's not going to be as straightforward as just a single line question. There would be a few, but not many. So let's move on to the next one. Which of these protocols is a connection-oriented protocol? So we're looking at FTP, UDP, TCP, and POP3. Now here we need to understand what these protocols are all about and which protocol works at which layer. And when we say connection-oriented protocol, what exactly does that mean? So when you say connection-oriented protocol, as far as this question is concerned, we're looking at 2 protocols, TCP and UDP, which work at the transport layer of the OSI model. And TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. We need to remember that TCP is a reliable protocol. It is used for reliability and to ensure that the data has been transmitted and has been received correctly, thus the reliability, which makes it a connection-oriented protocol. UDP or User Datagram Protocol is a connection-less protocol, which means that there are no established sessions that the protocol is going to maintain. And it's just going to dump data. So when you say connection-oriented protocol, TCP will maintain sessions with the endpoints and regulate data coming in and going through those sessions for that particular session that's going on, right? And that's the knowledge that you would have to evolve with and develop as far as CEH is concerned. So the correct answer here is TCP, the connection-oriented protocol. Then let's look at the next domain. Let's talk about analysis and assessment. So information security assessment and analysis, and looking at information security assessment processes. What kind of database is used in addition to relational database? Now that's a confusing question, right? They're talking about what kind of a database is used in addition to relational database. I have seen users getting confused where they say what kind of database is used in relational database, and they start arguing the question may not be correct. And this is where those certain keywords that we need to identify in the exam, in the questions in that exam, come into the picture. So they're talking about, apart from relational databases, what other kind of databases are there? And they have given you 4 options. Hierarchical databases, SQL databases, ODBC databases, and structured databases. Now, this is where the knowledge comes into the picture, where we know the types of databases. SQL or structured query language is basically a language that is used to interact with relational databases. ODBCs are drivers that allow applications to connect to databases. And relational database is a structured database. So the only option that is left is a hierarchical database, which is a kind of database apart from a relational database. There can be some similarities over here, but this is what the question is about, the types of databases. So if you look at it, you can change this to, in addition to relational databases, there are also what kind of databases? And the answer to that would be a hierarchical database. Then the next question, dash is used to audit databases. So when you go to audit databases, there would be a lot of tools out there, but we need to restrict ourselves to the 4 options that have been given here: ping, ipconfig, traceroute, and SQL ping. Now ping is an ICMP ping that is utilized by administrators to look at connectivity between 2 devices. ipconfig reveals the information of the IP configuration of that particular device. Traceroute allows you to trace how a packet is going to travel from one point to the end point. And SQL ping is the utility that is used to audit databases. And that's the correct answer. So out of the 4 options, which is the most appropriate answer? Somebody could argue that even ping can be utilized to look at auditing databases, which would give us the connectivity between the database server and the application server. True, but that's the connectivity, that's the network-based connectivity between the 2 devices. A SQL ping would actually ping to that database and see if that database is responding or not. Let's look at the next domain. Ethics of information security policies, laws, and acts. There would be a few acts or laws that would be covered in the training as far as the exam is concerned. For now, let's just look at which of the following prerequisites does an ethical hacker requires to start evaluating a system. So if I structure this question, what is the expected thing that I want out of the activity? I want to start evaluating a system, and they're asking me what are the prerequisites that an ethical hacker requires for that activity to happen. So is it a training? Is it permissions? Is it planning? Or is it nothing? Now, nothing cannot be an answer, right? If I want to evaluate a system and I have nothing, that's not going to help me. So training is a prerequisite, but it is a prerequisite to become an ethical hacker, not to start evaluating a system. Planning is a stage that you go through when you're an ethical hacker, where you look at how you can evaluate a system. And then you've got permissions. Without permissions, you cannot start a planning exercise. Because if you plan to hack something without permission, that means you're not an ethical hacker, you are a hacker. So the keyword again, what does an ethical hacker require as a prerequisite to start evaluating a system? So planning is out of the question because planning comes at a later phase. You have been trained. So what is the most probable answer over here? Permission, which is correct. Because without permission, I, as an ethical hacker, cannot start evaluating a system. What is a code of ethics? So when we say code of ethics, what would it translate into? Is it a law for expected behavior from an ethical hacker? Is it a corporate policy that is created by an organization for an ethical hacker? Is it a description of expected behavior, or is it a standard for civil conduct? Now, it cannot be a corporate policy because corporate policies differ. So if I go into one organization, I cannot have a different code of ethics from another organization that I'm working in. It has to be standardized. It has to be consistent. It is not a law because it is not implemented by a government. It is not a standard for civil conduct because, again, there is no government standards coming into the picture. So the most appropriate answer here is it is a description of expected behavior. A behavior that is expected from an ethical hacker that they need to adhere to. So for example, if I come across a vulnerability, the expected behavior from me is that I report that vulnerability to the organization and I do not keep it aside with a malicious intent to misuse it later on. So the code of ethics will basically describe what would be an acceptable behavior from an ethical hacker once they have started exercising their rights or start executing their jobs. Then looking at tools, systems, and programs. So information security systems, we're talking about information security programs and tools that would be utilized for ethical hacking. Now, it is important that you have hands-on on these tools as well, even if this is a theoretical exam, because we want to know what kind of commands are used by these tools, what is the output of that command, how we can analyze that command to reach a conclusion. Because in the exam, you're going to be straightforward asked about the conclusion at this point. So what does hashing preserve in a relation to data? Maybe in a practical exam, they would ask you how to hash data, and then you have the expertise, you hash that data and you provide the hashing mechanisms. They might give you a curveball saying we want to use a particular hashing algorithm and we want it in a particular manner and then we want to store it in a certain way. In a theoretical exam, they're just going to ask you about the concept. What does it achieve? What does hashing preserve in relation to data? What is hashing used for? Was it confidentiality, repudiation, availability, and integrity? So we first need to know the definitions, the technical definitions of all four from an ethical hacker's perspective. Confidentiality means that the data needs to be available to authorized users as and when they require it. Repudiation is the non-deniability of a transaction being happened and all the parties being held responsible for that transaction. Availability is the availability of that data when somebody wants to access it. And integrity is the trustworthiness of that data, which ensures the person who's authorized to access it that the data has not been tampered with and has not been manipulated by any unauthorized activity. And that is where your integrity verification comes in. So when we say hashing preserves what, hashing is basically used as an exercise to preserve the integrity of that data. That means the trustworthiness of that data. Then moving on to the next question, which one of the following is an example of a server-side scripting language? So we know that JavaScript is a scripting language. We know PHP is a scripting language, structured query language, SQL used for databases, and HTML, hypertext markup language that is used for your websites. Now, which of this is server-side and which of this is client-side? So SQL is used for databases at the server side where the application converts that language, but it's not a scripting language. HTML is again not a scripting language, so there are only two scripting languages over here, JavaScript and PHP. JavaScript is a client-side scripting language. PHP is a server-side scripting language. Thus, the answer to this question would be PHP. Then moving on to the next domain, let's talk about procedures and methodology from an information security procedures standpoint and information security assessment methodology. So the first question here, symmetric cryptography is also known as what? So the assumption of this question is we know what cryptography is all about and we know the types of cryptography. So there is symmetric and asymmetric cryptography. A symmetric cryptography is basically using the same key to encrypt and decrypt, and asymmetric is using public key to encrypt and a private key to decrypt. So if you're using the same key to encrypt and decrypt, that means that this is known as a shared key cryptography, where you're sharing the key with the intended user so that they can use the same key to decrypt it. Then you've got asymmetric encryption. So asymmetric encryption is also referred to as which kind of a following: shared key, public key, hashing key, or block key. So based on the topic that we have discussed and what you would learn in the ethical hacking perspective, you will know that this is also known as a public key methodology. Moving on to the next one, talking about security. Information security controls, information security attack detections. So the first question, physical security can prevent which of the following? So first and foremost, from an ethical hacker's perspective, the first confusion comes in: would an ethical hacker be responsible for physical security? And the answer to that is yes. Why? Because if there is a firewall on a server, but the server can physically be accessed by a hacker, and they can input a USB device in it, which may have a Trojan or a virus or something like that, that's going to circumvent any of the firewalls that you have placed on the system. So physical security is an important part of ethical hacking as well. And we need to know what part of physical security mechanisms can be implemented from a hacker's perspective. So the 4 options that we are given is a DDoS attack, FTP, tailgating, or cracking. Cracking is password cracking, FTP is a protocol, DDoS is a voluminous attack based on traffic that is created, and tailgating is actually a person tailing a person in to an organization. So that is where the physical security comes in. And tailgating is the activity, like I said, where a person tailgates another person, and basically, let's say there's an authorized person who has the authority to access a particular server room. They swipe their swipe card on a lock, open the door, and walk in, but they do not close the door behind them. And while the door is open, another person sneaks in without the knowledge of the first person, and thus a tailgating attack happens. So physical security at that point in time can prevent tailgating, whereas you can say, instead of the swipe lock, or apart from the swipe lock, you may have a guard over there or a CCTV camera over there who's going to monitor something. Which of the following is a good defense against tailgating and piggybacking? So we've just discussed what tailgating is. Piggybacking is another exercise where a person would impersonate someone and ask assistance to get access to a particular resource so that they can conduct their job. Now, in this scenario, camera would make no difference, because a camera is basically a detective mechanism. It is going to detect information, and if you're monitoring it, well and good. If not, then it wouldn't work. Guards, it is easy to fool guards. Turnstiles are those devices where you put in a coin, and there are 3 extensions to it. It revolves around and allows one person to go through, but they are easily bypassed. Man trap is a scenario where there are 2 doors. The first door opens, there's a CCTV camera monitoring everything. There are other security mechanisms coming in. The first door closes, and till then you have to identify yourself for the second door to open again. Till the first door closes, the second door cannot open. So you're trapped in between those. If you don't have proper authentication for the second door, even if you do a tailgating or a piggyback attack on the first door, you will not be able to bypass the second door. Thus, the answer to this question would be man traps. Now, those are the examples of questions that you may be asked, or the types of questions that you may be asked in your exam. And you can see that these are quite descriptive questions, if you will. The description, the assumption being the knowledge that is required, where you understand all the options that have been given to you, identify the keywords in the question, map them accordingly, and then try to identify the most appropriate answer that has been given in that particular options menu. So this calls upon a lot of intellect. It calls upon a strong analytical mind that in very small amount of time can analyze the question, come and deduce the correct answer, and then move on to the next question. Understand 240 minutes for 125 questions. If you go back and see how much time we have spent in just touching base on each of the option and just identifying what it means, you would basically then realize how much time it would take for your brain to analyze, crunch all of that, and come to the conclusion. So it takes a lot of practice. Then let's move on to job roles that are going to be possible once you become a certified ethical hacker. First and foremost, there would be a network security analyst. This job will involve taking out weaknesses in your infrastructure and finding creative ways to protect your company. So when you say network, you're talking about switches, you're talking about routers, you're talking about firewalls, UTMs, IDSs, IPSs, and that's all the knowledge that you'll have to develop to understand how networks work, how communications work. So we started off with the OSI layer. We need to understand how many layers are there, what layers what protocols work across these layers, and so on and so forth. And then we need to understand how routing is done, how the data packet is crafted, how a hacker would create a malicious data packet, what kind of attacks are possible on those networks based on the protocols, the data packets, and the inputs that have been allowed. And thus, your job would be to identify the weaknesses of the current configuration and then tweak that configuration to prevent those attacks from happening. Then there is a security specialist. This protect local, state, and federal infrastructure in the event of a disaster or terrorist attack. So this would be a government job where you're looking at government infrastructure and critical infrastructure from the government perspective. We are going to secure that infrastructure. Then a penetration tester. What is the difference between here? The penetration tester is basically a specialist who knows how to hack, and their specialty is just creating those attacks to see if those vulnerabilities that may have been identified can be penetrated, can be misused, can be bypassed, can be anything, right? So here you're going to attempt to breach a computer via a network vulnerability or an application vulnerability or a host-based vulnerability and try to get access to unauthorized information. Then an IT auditor. An auditor is responsible for the internal controls and managing risks to a company's technology network. Now, the first thing is, even if I've implemented a firewall, I need to audit the firewall for the effectiveness of that firewall. And I need to do it on a continuous basis, because if I create one firewall today, 10 days down the line, the firewall may not be as effective because of the ever-changing scope of information technology. New ports being opened up, old ports being closed down, the firewall rules keep on changing. There are requests coming in from employees for different permissions to be allowed or for restrictions to be implemented. And thus an auditor needs to be in place where they're going to audit all of the security mechanisms that we have in place and ensure that they're effective enough. And then there's a security engineer's job role as well, where they are supposed to set up security measures to monitor, protect data and systems from hackers and cyber attacks. So this is the defensive mechanism where it comes in, where you identify where firewalls can be placed, what kind of firewalls can be placed, how to configure them and secure the infrastructure. Most of the organizations in today's world that are IT organizations or IT dependent organizations or IT enabled organizations, whichever way you look at it, any organizations that uses information technology for their business to be executed will be looking for certified ethical hackers to audit, to penetrate, to test, or to secure their infrastructure. All right, so there would be multiple job roles. And these are some of the organizations on the screen that you see that hire ethical hackers. Most of your major organizations like Google, Facebook, Apple, Dell, all of these organizations have a very robust security teams, and they are on the watch out for ethical hackers on a regular basis. So once hired, what is the salary of an ethical hacker like? What would you expect? So in US, the pay scale, now this is a source from payscale.com, and the pay scale for a certified ethical hacker would be around 70,000 odd US dollars per annum. In India, it would be 5.5 lakh rupees per annum, and it starts from there. So it can move on to, depending on the experience that you have, depending on the knowledge that you have, depending on the achievements that you have achieved during your career, the salaries could skyrocket. This is the average salary that is paid for a CEH in the US and in India. So that is what we were going to discuss for this video. I thank you for watching the video, and I'll see you in the next.
Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.